Imagine balancing a 100-pound, 24-foot metal spear vertically on your fingertips.
Oh, yeah. Not easy.
Right. Now imagine doing it blindfolded by heavy smoke with a stopwatch running, all while, talking continuously out loud to yourself.
It's an incredible amount of stress.
It really is. And today we're looking at the exact performance script that forces professionals to master this kind of extreme multitasking. So welcome to our latest deep dive. We're exploring a really fascinating source document today. It's called the GLEL Deploy 24-Volt Extension Ladder.pdf.
Which I know sounds like a completely dry instruction manual.
Right, like something you'd find buried in the bottom of a toolbox. But it is anything but. This is the precise performance script for the Florida Firefighter Minimum Standard State Exam. Specifically, it covers the one firefighter raise for a 24-foot extension ladder.
And we should clarify, a 24-foot extension ladder is an incredibly demanding piece of equipment to handle alone under the best of circumstances, let alone in a high-stakes testing environment.
Exactly. And the mission of this deep dive is to uncover exactly how firefighters train to turn these really complex physics and strict safety protocols into absolute muscle memory. The scenario is intense. The firefighter has exactly 4 minutes and 40 seconds to perform this entire solo operation.
And the real kicker here is the talking.
Yes, they have to do it while continuously dictating their actions out loud to a state examiner. For you listening, whether you're climbing the corporate ladder or, well, a literal one, the way these professionals manage cognitive load and physical stress is an absolute masterclass. So let's unpack this, because before the firefighter even touches a single piece of equipment, there's this striking paradox.
Right. The clock is already ticking.
The clock is ticking, but they cannot move toward the ladder. They have to stand there and deliver a highly specific monologue.
Yeah, the pre-task brief, it is honestly a brilliant constraint. The examiner forces the candidate to verbally confirm their mental state and their situational awareness before any physical exertion begins.
So they have to prove they're ready.
Exactly. The firefighter has to state out loud that they are in full PPE. They must declare they will notify command of their assignment and that they'll continuously monitor their physical condition.
Hold on. Let's clarify for anyone outside the fire service.
Yeah.
Full PPE is personal protective equipment, right?
Yeah.
Like the bunker gear, the helmet, the heavy boots. But the document also mentions stating what they will do if they are operating in an IDLH environment. What exactly is an IDLH environment?
So that stands for immediately dangerous to life or health.
Oh, wow. Okay.
Yeah, it's an atmospheric condition that poses an immediate threat to life or would cause irreversible health effects. So think like a smoke-filled room or an area with a chemical leak.
Right.
If they're in an IDLH environment, the firefighter must declare, I will go on air, which means they'll use their self-contained breathing apparatus. They also have to confirm they communicate with interior and exterior crews, make sure utilities are shut down, find a second means of egress, and work on the windward side to avoid having smoke blow directly into their face.
It's like an airline pilot's pre-flight checklist. But you have 4 minutes and 40 seconds to get this heavy ladder off a truck and raised against a building, yet you're forced to stop and recite what sounds like a legal disclaimer while basically sprinting toward a burning building.
It does sound like that, yeah.
So why is the verbalization so critical here? I mean, why not just test their physical ability to raise the ladder and then give them a multiple choice written exam for the safety checks later?
Well, because the state examiner is testing for the realities of human biology. In an emergency, your brain naturally wants to default to tunnel vision.
Okay.
Your amygdala, the part of the brain responsible for the fight or flight response, it detects a massive threat, like a fire, and it just floods your system with adrenaline.
Right, your heart rate spikes.
Exactly. Your heart rate spikes, your peripheral vision actually narrows, and your instinct is to just grab the gear and sprint blindly at the problem. But sprinting blindly gets you killed. By forcing the firefighter to speak these steps out loud, starting with repeating the order back, like command, copy, deploying one 24-foot extension ladder, it acts as a cognitive anchor.
So the talking forces the brain to stay engaged.
Precisely. It intentionally engages the prefrontal cortex, which governs logical decision-making and sequence planning. By verbalizing the checklist, the firefighter proves to the examiner that they haven't been hijacked by their own amygdala.
Wow.
They're maintaining communication, they're aware of the hazards, and they're operating with intentionality rather than just, reacting on pure adrenaline.
That makes a lot of sense. So the talking is essentially a psychological tether keeping them grounded.
Exactly.
Once that mental checklist is locked in, we move to the physical retrieval of the gear. And the choreography here is meticulous. Every single bodily movement is scrutinized. They have to disengage the locking devices on the fire engine, keeping their back straight, lifting with their legs, and they must narrate it using proper body mechanics. Back straight, lifting with my legs.
And that narration must match the physical action perfectly.
Right.
If they say lifting with my legs, but they actually bend at the waist, they're penalized.
Now, once they start pulling the gear off the truck, there's a highly specific detail in the source material that caught my eye. Often they have to remove a smaller roof ladder first to get to the main 24-foot extension ladder.
Right, because of how they're stacked in the compartments.
Right. And the document strictly mandates that when placing this roof ladder on the ground, they must ensure it's placed far away from the exhaust side of the apparatus. Wait, exhaust? That feels like such a minor, almost trivial detail when you're preparing to fight a fire. Why is the exhaust such a specific enemy here?
Well, what's fascinating here is you have to consider the mechanics of a modern fire engine. These are massive diesel vehicles. Their exhaust systems, especially during regeneration cycles, output incredibly intense heat.
Like, how hot are we talking?
Sometimes upwards of 1,000 degrees.
1,000 degrees.
Yeah.
From the exhaust.
Yeah, along with concentrated diesel fumes, carbon monoxide, and corrosive particulates. If you place a ladder directly in that exhaust path, you're exposing it to a severe chemical and thermal assault.
So it's not just about the ladder getting a little dirty with soot. It's an actual hazard to the equipment.
Exactly. Modern ladders are often made of fiberglass or aluminum. Extreme localized heat can warp aluminum or degrade the structural resins in fiberglass before the ladder even touches a building.
Oh, wow. I didn't even think of that.
And beyond the material science, think about the human element. You are forcing a firefighter who is about to engage in extreme physical labor to bend down right by the exhaust and take a deep breath of concentrated carbon monoxide.
That's terrible.
Right. It's a dual-purpose safety protocol. You protect the structural integrity of the equipment, and you prevent the human from inhaling toxic fumes right before they need peak cardiovascular performance.
That is wild. The exhaust is practically a solvent to the ladder's integrity if they aren't careful. Okay, so the roof ladder is safe. Next, they remove the 24-foot extension ladder. The required carry here is a low shoulder carry with the bed section against the body,
Right.
carrying the butt end forward and slightly lowered.
Correct.
But before they even take a step toward the building, we hit a critical fail point in the document. The firefighter must look up, look down, and clearly declare, "I have no overhead obstructions and my terrain is clear."
Yes. And the examiner must clearly hear this statement, and they must see the head movement. If you skip this or if you mumble it, the evolution is compromised. You fail.
Why is this single sentence treated with such zero tolerance?
Consider the physical reality of carrying a 24-foot ladder on your shoulder. Your vision is severely restricted by the beam of the ladder resting right next to your head.
Right, it's basically a blinder.
Exactly. So if you don't intentionally break your focus to scan the environment, the consequences are catastrophic. A power line hidden in the trees overhead could mean instant electrocution the moment you raise the metal ladder. Or a small ditch or debris on the ground could snap an ankle. The mantra forces them to verify the three-dimensional space before they commit to moving through it.
So the path is verified clear, and the firefighter finally reaches the target structure. This brings us to the raise itself, which the deep dive reveals as this massive high-stakes balancing act. They kneel, always using their legs, and place the ladder flat on the ground. Then they move to the tip, slide the butt into the base of the building, and essentially push the ladder up the wall until it's perfectly vertical.
Yes, and as they lift it, they're verbalizing, raising ladder using my legs, maintaining contact with the ladder.
Right. But here is the part of the source material that really caught my attention. Once this massive ladder is perfectly vertical and flush against the wall, the protocol dictates that they must intentionally pull the base of the ladder away from the building, exactly 12 to 24 inches.
Yep.
To me, that sounds incredibly risky. It's like balancing a giant heavy pencil on your finger. You finally have it resting safely against the wall. Why pull it 1 to 2 feet away? Why not just leave it flush against the wall to keep it from falling backward onto you?
It does seem totally counterintuitive at first glance. But if we analyze the physics of momentum and leverage, that specific 12 to 24-inch measurement reveals a brilliant built-in failsafe. Think of a 24-foot ladder as a massive lever.
Okay, with the ground acting as the fulcrum.
Exactly. If that ladder is perfectly vertical and flush against the wall, its center of gravity is neutral. If a sudden gust of wind hits it or the firefighter simply shifts their weight the wrong way, the only direction that heavy lever can fall is backward.
Directly onto the person holding it.
Right, and you'd have to try and muscle a falling 100-pound lever to stop it from crushing you, which is nearly impossible once it gains momentum. But by pulling the base back just 12 to 24 inches, you alter the center of gravity. You create a slight inward angle.
Oh, I see.
If the firefighter feels the ladder starting to get away from them, or they start losing control due to fatigue, they don't have to fight the physics. They simply let go. Gravity takes over, and the ladder safely falls forward, resting against the building. The protocol relies on gravity as the primary safety mechanism instead of human muscle.
That is such a fascinating application of physics. So the ladder is resting at that slight inward angle. The next step is extending the fly section to actually reach the target height. And for those listening, the fly section is the moving part of the ladder that telescopes upward while the bed section stays grounded. They pull a rope system called the halyard to raise it.
And once it's at the correct height, the firefighter must execute another crucial visual and verbal check. They must look at the locking mechanisms, which are called the dogs, and declare out loud, "Both my dogs are locked."
The dogs. Fire service terminology is so unique, so these are the metal hooks that snack over the rungs to keep the extended fly section from sliding back down under weight.
Correct. If those dogs are not fully seated over the rungs, the moment a firefighter steps onto the extended fly section, the ladder will violently telescope back down to its original size.
That sounds terrifying.
It is. Visually confirming and loudly declaring, "Both my dogs are locked," guarantees the mechanical integrity of the extension.
Okay, so the telescope is locked. But we aren't ready to climb yet. The ladder is extended high into the air, but the base is still only that 1 or 2 feet away from the wall. We have to get it into its final safe climbing position. And this brings us to a transition that is essentially a masterclass in spatial awareness and material science. The firefighter now has to move this fully extended, top-heavy 24-foot ladder backward. So the base is approximately 6 feet from the building.
And the source document outlines a very strict rule here. No walking backwards.
Hold on, how do you move a ladder 6 feet backward without walking backward? Are they sidestepping? Because that sounds like a tripping hazard in itself.
They aren't sidestepping, and they definitely aren't blindly backing up. The procedure requires them to face the building. They sweep the slack of the halyard rope under the ladder so it's out of the way. Then they grasp rungs 2 and 5. They slightly lift the ladder and walk backward with the ladder, keeping their body squarely behind it.
Okay, but isn't that walking backward?
The strict no walking backwards rule generally means you never walk backward without a physical grounded reference point or without visual confirmation of your path. The entire time, they must tilt their head up to monitor the tips of the ladder sliding down the wall. By keeping the ladder between them and the wall and watching the tips, they maintain a continuous spatial reference. If they trip while doing this, their forward momentum pushes the ladder into the building, rather than pulling it down on top of themselves.
Incredible. So the base is now 6 feet out. Next, they have to deal with the halyard rope, which is just hanging there loose. The protocol requires them to keep a foot against the ladder base to maintain control while they pass the excess halyard through the ladder, pull it taut, and tie a highly specific knot. It's a clove hitch on a bight around an upper rung, followed by a safety knot, all while narrating it out loud. Why is the clove hitch the universal standard here?
It comes down to the friction mechanics of the knot under tension. A clove hitch essentially crosses over itself. When you apply a load to it, say, a firefighter's boot accidentally catches the rope while climbing, the knot pinches down on itself. The harder you pull, the tighter it binds against the rung, meaning it absolutely will not slip.
And what does on a bight mean?
A bight aid is simply a loop in the rope. Tying the clove hitch on a bight means that instead of pulling the entire end of the rope through the knot, you just push a loop through. The genius of this is rapid release.
Oh, for when they need to take it down quickly.
Exactly. When the emergency is over, the firefighter doesn't have to waste time untangling a tight knot. They just pull the loose tail of the rope, the loop pulls through, and the entire knot instantly falls apart. It is maximum security under tension. with zero friction on the release.
That is elegant engineering. Now the knot is tied, but here's where it gets really interesting. Depending on what the ladder is made of, the firefighter might have to completely pivot it. The document dictates a fascinating rule based entirely on the ladder's material. If it's a metal or fiberglass extension ladder, it must be positioned with the fly section facing out toward the climber. But if it's an older wooden extension ladder, the fly section must be positioned in, facing the building. Why does the material change the physical orientation of the ladder?
This touches on the structural engineering of load-bearing equipment. Older wooden ladders are constructed using mortise and tenon joints, where the rungs are set deeply into the wooden rails, often supported by tension rods. The geometry of a wooden ladder requires the weight of the climber to push the moving fly section into the main bed section, compressing the components together for strength. Therefore, the fly must be on the inside.
And metal ladders don't need that compression.
No, modern metal and fiberglass ladders use extruded materials with different welding and bracket systems. They're specifically engineered with overlapping rails and heavy-duty guides. For these modern materials, the structural strength is optimized when the fly section rests on the outside, physically resting on top of the bed section's hardware.
So the examiner is literally checking their material science knowledge on the fly.
Literally. The state examiner is actively listening for the candidate to acknowledge this material difference by stating, pivoting ladder left, followed by fly section positioned out.
Every single detail is highly calibrated. So we've moved the ladder out, we've tied the knot, we've accounted for the material science of the pivot. But how do you know if the climbing angle is actually perfectly safe? If it's too steep, you fall backward. If it's too shallow, the ladder snaps under your weight, or the base slides out. You can't exactly pull out a protractor on the fire ground.
No, you use your own anatomy as the protractor.
I love this part.
It's brilliant. The source document calls for a specific physical verification. The firefighter places the toes of both boots directly against the butt of the ladder. They stand completely straight and then extend their arms horizontally at shoulder level.
The arm's length test.
Exactly. If the angle is mathematically correct, the firefighter's extended hands will perfectly grasp a rung between the beams. If you have to lean forward to grab the rung, the ladder is too steep. If your arms remain bent because the rung is too close to your chest, the ladder is too shallow. Human anatomical proportions naturally measure out the ideal 75-degree climbing angle.
And then they have to narrate it, right?
Right. They perform this posture, confirm the fit, and state, I am at the proper climbing angle.
Using your own body proportions as a safety instrument is just incredibly smart design. So the ladder is set. The angle is perfect at 75 degrees. The knots are tied. But before a single boot touches a rung to begin the actual climb, the examiner is waiting for the climax of the verbalization test. The document explicitly warns candidates not to rush this next part.
It is the ultimate 5-point mantra. The firefighter must stand before the ladder and declare 5 specific conditions clearly and deliberately. First, I have 4 points of contact. This confirms the 2 base feet are planted firmly on the ground and the 2 top tips are resting evenly against the structure.
Second, both dongs are locked, confirming the mechanical extension won't collapse.
Third, halyard is tied and secured, ensuring there's no loose rope to trick the climber.
Fourth, I am at the proper climbing angle, validating the 75-degree geometry.
And finally, the ultimate confirmation. My ladder is safe and secure to climb.
My ladder is safe and secure to climb. By saying that out loud, you are taking complete, undeniable ownership of that safety environment.
It removes all ambiguity. In a real emergency, with alarms blaring and people relying on you, this ingrained checklist forces a momentary pause. It's a critical breath that prevents a catastrophic, adrenaline-fueled mistake just seconds before committing your body weight to a structure suspended high in the air.
But the operation isn't quite over, because this is a one firefighter raise. The single firefighter has done all the setup, which implies another crew member is now going to climb it. This brings us to the final phase, heeling the ladder.
Heeling is the act of securing the base of the ladder to prevent it from slipping while someone else ascends. There are 2 approved methods detailed in the document. The underneath method, where the firefighter stands beneath the ladder facing the building, grasping the beams at eye level and pushing forward.
And the other one.
The outside method, standing on the outside, pinning the bottom rung with 1 foot and pressing the ladder horizontally into the building.
So essentially, they are becoming the human anchor. They are wedging their own body weight at the bottom to counteract the leverage of the person climbing at the top.
That's a great way to visualize it. And the crucial element here is hypervigilance. While acting as that anchor, they must look up and state, watching for falling debris, watching for descending personnel. They cannot let their guard down.
Which means they are physically locked into that position. The test isn't over until they properly transfer that heavy responsibility. They must continue healing until they are officially relieved by another firefighter stating loudly, "Safeties, please take my ladder." And they cannot let go until that transfer is acknowledged.
It perfectly illustrates the chain of custody for safety. An active ladder is never left unattended.
When you zoom out and look at all of this together, what initially seems like a mundane task, just putting a ladder against a wall, is revealed to be this highly calibrated 4-minute and 40-second symphony of physics, geometry, and extreme psychological discipline. Every pivot, every specific nut, every calculation of momentum is designed to mitigate disaster. And the connective tissue keeping it all together is that constant verbalization. It proves the firefighter is in control of the situation, rather than letting the chaos of the situation control them.
It is the ultimate cognitive tool for overcoming our own hardwired panic responses. It's knowledge applied perfectly under pressure.
Exactly. Now think about the high-stakes, stressful moments in your own life. How many mistakes could you avoid if you forced yourself to verbally dictate your actions and physically confirm your 4 points of contact before taking that first dangerous step? And it leaves us with a really interesting, kind of provocative thought about the future. As we rely more on technology, there's a push to equip firefighters with augmented reality masks.
Oh, the heads-up displays.
Right, visors that automatically project digital checklists, thermal readings, and angle measurements right before their eyes. It's an amazing technological leap. But you have to wonder, if a digital screen starts checking off the boxes for them, do we risk degrading that life-saving cognitive anchor?
That is a very real concern.
If a firefighter no longer has to force their prefrontal cortex to verbalize the safety of their environment, what happens when the battery dies or the screen fogs up in the middle of the chaos? Without the habit of talking out loud, does the amygdala take back over? Something to mull over. Thanks for joining us on this deep dive.